Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at the PathName and PathScan commands. Today we're going to be looking at two commands that are inbuilt to PowerBasic, the PathName command and the PathScan command. The PathName command allows you to parse a file name or path and file name without the file needing to exist in the storage medium. So first of all, we're going to create a local variable called file, and we will populate that with a file name and a path that does not currently exist on this computer. So there we have a variable populated with a string of characters, which is the path to the file and the name of the file itself. And we will create a function called PathName, taking a single parameter, which is a variable holding the path and the name of our file. So let's go and create this new function. So here is the skeleton of our new function taking its single parameter. We'll create a local variable called value, which is going to be populated with each of the elements of this string. So our first call to the PathName command will be using the full option. This will return the entire string passed into our function. And we will push that out to our log to indicate this is the full string. So let's try running the application now and see what we get. So there on our log is the word full followed by the full string we passed to the function. We're now going to use the PathName command 4 different ways to give us the path, the name, the extension, and the name X. So let's go back to the function and amend the code. So first of all, we're going to use the path option. PathName takes two parameters. The first is the director, telling the command what we wish to do, and the second parameter is the entire string holding our file name and path. So using the path option, if we run the application once more, we will see we're now getting the path excluding the file name. This includes the slash at the end of the folder. So if we step through the remaining options of name, extension, and name X, we'll see how this is going to chop up this file string. So we will see the name gives us the name of the file excluding the extension. The extension option gives us just the extension, and namex gives us the file name plus its extension. So using this single command, you can pull out from any string any part of the path or file name you wish. Or you can still perform this type of action using a number of other string commands. This does it all on one line of code, and is particularly useful when you're pulling information out stored medium. Plus the additional advantage is that the file name does not need to exist on a storage medium. Now let's go back to our code and look at the PathScan command. PathScan can be used to search for a named file and parse what is returned. So we will first populate our file variable with the name of a file, in this case pathcommands.bas, which is the name of this basic file. Next we're going to declare a local variable called pathSpecification. This variable is used to specify where we want the PathScan command to look. This can contain a single directory or multiple directories. We will start off with a single directory, and we're going to create a function whose job it will be to run our PathScan. And we will pass it the two parameters, the variable containing the file name and the variable containing the path specification. So let's now go and create this function. And here is the skeleton of our function, taking its two parameters. With the PathScan command, the path specification is an optional parameter. If it is not given, or if it is given but is 0 in length, then the directories which are searched, as we can see below, are searched until a single match is found. Please note that the search is not recursive. It will not go into subfolders. The first directory searched is the one where the application was loaded from. Next, it will search the current directory. and then it will start to work down the Windows system directories, the Windows directory itself, and then finally the directories in the path environment variable. As soon as it finds a match, it will stop searching. So as we did in the previous function, we're going to set up a local variable called value to hold the results of our PathScan. So here is the command to call PathScan$. We're using first of all the full director. This will give us the full path to the file if we have found it. So let's run the application now and see what we get. And there in our path name is the path to the file. It has found pathcommands.bas and given us the full path to that file. So if we change the name of the file we're looking for to look for a file that does not exist, and if we run that now, we will see the result coming back is an empty len string. So in this case, it has not found the file. So as before, we have a number of other directors. If we look at using just the path command to return only the path but not the file name, it will do exactly what you expect. It will return the path itself, but excluding the file name. But it does have the / character on the end of the path. So if we now add the remaining directors, name, extension, and namex, we will get the values as we did in the previous function. So we now have the name of the file, excluding the extension on its own, the extension and the file name together. So the PathScan command gives you a way to slice up the string, which is the file path and the name of the file, into its individual elements. This is particularly useful if you need to store this information in different parts of your system, perhaps in a database. The user in your application may have selected a file and you want to store that information for later processing. So we have used the PathScan command to scan a single directory for a particular file. What if we wish to search more than one directory? What we're doing now is we're populating the path specification variable with two folders. First of all, the exe path, which is the folder which our executable currently sits in, delimited by a semicolon. And the second folder is a directory which is a subdirectory of the directory we're currently in. And we're looking for a file called testfile.txt. As you can see from the file manager on screen, we do indeed have a file called testfile.txt in the root of the code folder. So if we ran our PathScan function now, it would find this file in the first place it's going to look, the exe path. So if we ran the application now, it would pull back the information on testfile.txt. If we look in the subfolder, which is the second folder it's going to look for, it also has a testfile.txt. But the application did not search this as it found it in the first directory. However, if we rename the first file and run the application once more, it should look in the first directory, the exe path, not find a file, and then look to the second directory. Which it has indeed done. It's now looking in the subfolder and has found a file in the subfolder. So PathScan can be useful if you want to look in a number of locations to find the first iteration of the file you seek. However, what if the user has a mapped drive? On screen at the moment, we can see our Z drive. As we can see from the top of this file explorer, it's a mapped drive to another computer called Odroid006 into a shared area folder. So how can we tell the difference between a mapped drive containing the file we're looking for and a folder which is on a local volume? To achieve this, we're going to use a Windows API call. So we're going to create a new function called path2unc. So we will set our path specification to the Z drive. And we're still looking for a file called testfile.txt. So we're going to create this new function, path2unc, taking its single parameter, which is the current path specification. Windows API functions are very useful as they give you access to a great deal of code inside the Windows operating system. We're going to use a pointer here to a user-defined type called universal name info. And we're going to create a local variable called ASCII-Z, which is a fixed length string for the length of the maximum path. And then we're populating this pointer using the var pointer command. This gives us a way of passing this information on to the Windows API call that we wish to use. And the return from this function is at the bottom of the screen. We're going to be returning the information held within the variable which we're pointing to using puni. So let's try running this application now to see what this new function will return. So there at the bottom of the screen is the PathName mapped URL. Rather than returning the path to the Z drive, it's returning the true path to the file, in this case the Odroid 006 shared area testzone testfile.txt. And the director is used to chop up that string into its various parts. So if the user selects a file from a mapped drive, we can pick up its actual location on whichever computer it sits. So can we use this function for something that isn't a mapped drive? Or do we have to assume it has to be mapped? Let's go back to the code. Prior to calling this latest PathScan function, we used our path to UNC. So in order to always determine whether the path we're picking up is a local volume or a shared volume on another computer, we need to make a small amendment to our path to UNC function. We will pick up the output from this line of code and put it into a local variable called output. If the data within this output variable is a zero-length string, then it's a local volume and not a shared path on another computer, in which case we will just return what we took in at the beginning of the function, the input path. If the value returned is actually something other than an empty length string, then it is indeed a mapped drive on another computer. So we will return the output from our function. And back in our code, we are wrapping the path to UNC function around each of the paths we're going to put into the path specification. First of all, the exe path, and secondly, the hard-coded path to our H drive. If we have a look in our H drive, we can see we have the testfile.txt in the root of the code folder, which is the first place it's going to look. So if we run the application now, we will get the path name finding it in the root of the code folder. If we amend the name of this file so that it will no longer find it in the root, and run the application once more, we will find it finds it in the subfolder of our local volume. So we now have a function which works regardless of whether the file is local or the file is a mapped drive on another computer. And it's returning the true path from this computer to that file. So in summary, what we've done today is we have covered two inbuilt commands to PowerBasic. The PathName command, which parses a file name or path without the need for the file to exist in the current storage medium, allowing you to chop this string up to its various elements. We've also used the PathScan command to search for a named file and parse what is returned. We've additionally used a Windows API call to allow us to determine whether the path we're looking for is a shared folder on another computer, or look to see whether the file is on a local volume. Hopefully you'll find these commands useful in your own applications, but that's it for today. Thank you for watching.